So, our favorite student, good old Ann. Okay. On your test, the biggest challenge in this, Jake, is not the math. We've multiplied and occasionally we've subtracted 1. That's all the math we've done so far. It's been times. Oh, and then every so often it was go 1 by 1, 1 on 1, 7, 8, 6, 5, that kind of a thing. 7, 6, 5, 4, 3, 2, 1. The biggest challenge is, what approach do I use when? So my first hint for you is actually, Christina, I will probably on your test go in the same order that I've taught you. In other words, I'll tell you the first question on your test right now. It's going to be a fundamental counting principle question, draw blanks. Probably the first couple of questions. Probably somewhere in the first couple of questions is going to be a Scrabble bag approach. Oh, then we'll probably get into the permutations where you can start to use factorial. And then we'll get to today's stuff a bit later on today. So number 1, I'm thinking fundamental counting principle, even though I haven't read it, just because I'm a good test writer and I can think like a teacher. Let's see. Mr. Dueck is purchasing a new Lamborghini sports car on his teacher's salary. He has a choice of 6 colors, 3 body styles, 4 interior packages, and 3 tire styles. How many different choices of Lamborghini? You know what? I think this is going to be colors, body styles, interiors, and tires. I think I have 6, 3, 4, 3. It's going to be 18 times 12. That's kind of yucky. It's going to be 24 times 9. Well, 24 times 10 will be 240, so 24 times 9, 216? Did the math in my head, because it's arithmetic. Okay. 1 mark. How many ways are there to arrange the letters of the word complainers? I don't know why I thought about that word when I was typing this quiz up and thinking of you guys, but okay. Now we have to ask, do any letters appear twice? Do any letters appear twice? Okay, so I can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 11 letters long? So you can do this either as 11 factorial, or you can go from 11 permutate 11, or you could draw 11 blanks because it is going to be 11, then pick 10, then pick 9, then pick 8, then pick 7. I'm not going to draw that one out. What the heck is 11 factorial? Good question. Oops, I don't want this calculator out. We're using this calculator in this class. Menu, option, number. No, I don't want option number. Probability, that one. 11, it's going to be big, I'm guessing. 399,168 2 zeros. I guess 39,916,800. How many 7-letter arrangements are there of the word ambidextrous? Okay, do any letters appear twice? Oh, so I don't have to do that whole divided by thing. Am I picking all of them? No, I'm picking 7. How many letters are there grand total? 12. So this is going to be from 12 permutate 7, which, by the way, according to our formula, is this. It's 12 factorial over 5 factorial. Not 7 factorial, 5 factorial. Because that would cancel the 5, 4, 3, 2, 1 on the top and just leave you with a 12, 11, 10, 9, all the way up to 7. Because the formula, if you look on your yellow formula sheet, the NPR is defined as n factorial divided by n minus r fact. That's the actual how it's defined as. That's what we're doing. Because, so who asked that? Was it Brooke? So what we're saying, Brooke, don't write this down, but what we're saying is, look, if you go 12 times 11 times 5 times 4 times 3 times 2 times 1 on the top, and you divide by 5 times 4 times 3 times 2 times 1, those cancel. That gives you a 12, 11, 10, 9, 8, 7 stop, which is what I want if I was drawing blanks. I'd draw 7 blanks, and it would be 12 for the first one, 11 for the second one, 10, then 9, then 8, then 7. Did I miss anything? I think I was right. Anyways, it's going to be whatever that is. 12, permutate, 7 at a time. Oh, almost the same number as before. 3991680. That's a fluke. Don't think that that's going to happen. That's just completely a fluke. One mark. How many three-letter arrangements can I make from the word campgrounds? Well, no letters appear twice. Campgrounds has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So it would be this, 11P3. That answer doesn't appear there. But Brooke, then what you need to realize is we defined NPR as n factorial all over n minus r factorial. So this goes back to your question, kiddo. It's going to be 11 factorial all divided by 11 take away 3 factorial. What is 11 take away 3? This is 11 factorial over 8 factorial. C. So this time, instead of actually asking you for the answer, I asked you for the procedure. Turn the page. How many 4-digit numbers can I make from the following group? How many digits? 4 digits, 4 blanks. I could probably do this with a permutation, except, I'm not going to go with I'm going to fall back on the fundamental counting principle. I'm not going to go with my shortcuts because there's a problem here. There is a restriction. I didn't say it in the question, but what's the restriction? When we're making up numbers, what can't we begin with? So I'm going to say this. I'm going to draw a 0 with no 0, which means how many choices do I have for that first digit actually? 5. And then a good way, this is why I do the Scrabble bag, although this time I kind of drew the Scrabble bag for you. I've said to a few of you, Sean, if you're not sure now, make up an example. Let's suppose I picked a 5. Cross it out. There's one possibility. How many are left to pick from? Are there any more restrictions now? How many are left to pick from? Okay, I picked the 9. Oh, can we repeat? Did I say without repetition? No, I did not. So I guess actually it's going to be, don't cross them out. It's going to be, you got 5. Oh, sorry, Mr. Dueck. I've got 6 to pick from, 6 to pick from, and 6 to pick from because there's no more restrictions, don't I? Ooh, I got to read these carefully. It's going to be 5 times 6 to the 3rd, 1,080. 5 times 6 times 6 times 6, but instead of doing that, I went 6 to the 3rd power. Okay, 1,080. Ooh. If it had been without repetition, then my method would have been correct. And the moral of the story is read carefully. How many permutations are there of the word Mississippi? Okay. Do some letters appear more than once? So now we have to use that last trick that we learned. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be 11 factorial divided by how many M's? 1. How many I's? 4. How many S's? 4. I've done the I's, I've done the, and 2 P's. Mr. Dueck? Yes, Roy? Why didn't you put a factorial on the 2? I'm so lazy, I know that 2 factorial is just 2, so I didn't even bother typing it. Do you get 34,650? How many permutations are there of the word Chilliwack? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. 2 C's, 1 H, 2 I's, 2 L's, 1 W, 1 A. I already did the C's, already did the K's. It's going to be that. 10 factorial divided by, oh heck, 2 times 2 times 2. 2 factorial, but who cares, because that's the same. Oh, syntax error, Mr. Dueck. Oh, I missed a 2. 2 times 2 times, times, Mr. Dueck? How about that? 2 times 2 times 2. Do you get 453,600? And the last one, pathways. Pathways. It seems to me, my friends, that for me to get from point A to point B, I am going to have to go down 2, 3, 4, 5, 6. I'm going to have to go down 7 times somewhere along the way. Yes? And I'm going to have to go right 4 different times. I can mix up the orders. Hey, that's a word. That's a word with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. 7 of which are going down, 4 of which are going to the right. Cool. Oh, 330? And there's no way you could list all those without missing a few, but I know there's exactly 330. Okay? By the way, some of this, if you're ever wondering how computers design airline routes and airline flights, it's basically a giant network like this, and it starts looking at optimal paths and pathways. We're starting to do also some network theory. Some. It's much more complicated, but it starts here. Can you give yourself a nice clear score out of, count them, 8, please? So, folks, my goal is, hey guys, let's go. Back row there. Pass the notes down, please. Did everybody get one? My short one? Okay. Now, as I was saying, folks, my goal, have you guys got a 4-day weekend? My goal, no homework for the weekend. I'm probably going to teach till most of the end of class. I won't finish this lesson. We'll pick up with this when I see you guys again a week from today on Wednesday. Combinations. Okay? Combinations. Or when order no longer matters. When we don't want to count the order as a different situation. When all we want to know is, are you in or are you out? If 5 sprinters compete in a race, how many different ways can the medals for first, second, and third place be awarded? Do you hear here we're talking about order because it's different if you finish first, as if you finish second, as if you finish third. You'll get a different medal. This is there are 3 places. You got 5 people who can finish first, 4 people who can finish second, 3 people who can finish third. The order matters, because finishing third is different from finishing first. Or the other way you could do this is you could say from 5 runners, permutate 3 of them. And there are, hey, what is 5 times 4 times 3? There's 60 different ways, 60 different orders that these people can finish in first, second, and third. So does the order of finish matter here? Absolutely. This is an example of a permutation of 5 objects taken 3 at a time. Let's suppose, so the Olympics, right? Gold, silver, bronze. Let's suppose instead of the Olympics, we're just talking about the qualifying. You guys with me? The qualifying for the Olympics, you don't really care whether you finish first, second, or third. All you care about is, do I finish in the top 3 that I get to go to the Olympics? I mean, first is nice. But no, maybe I'm saving myself for the Olympics. Maybe I don't want to overdo it right now. All I want to do is know, am I in or out? So example 2 says, suppose the 5 sprinters compete in a race, and this time the fastest 3 qualify for the next race. Does the order that you finish in matter then? Nope. All you want to know is, did I make it in the top 3 or didn't I? I don't care whether I finish first or second or third. I just want to know top 3. How can we figure that out? Well, turns out you can visualize it as a word, because you're going to have 3 people that are in, I'll say yes, I'll call that Y, and 2 people that are out, I'll say N for no. That's a word. Hey, how many letters in this word, grand total? How many Y's? How many N's? By the way, what do you notice when you add those 2 bottom numbers together? They equal the... Okay, what we're trying to do is look at this example to see if we can come up with a general new formula for when order doesn't matter. By the way, what is 5 factorial divided by 3 factorial, 2 factorial? 10? Okay. Does the order of finish for the fastest 3 matter here? Nope. And we call this, when order doesn't matter, we call it a combination. Here's your new word, a combination. Permutation is an ordered arrangement. Combination is in or out. Don't care when, just care in or out. We call this a combination of 5 objects taken 3 at a time. So, an unordered arrangement where you don't care about the order of distinct objects is called a combination. And here is the formula for calculating it. We write it as NCR, C for combination or choose. And it's n factorial divided by r factorial n minus r in brackets factorial. Write that down and then see if that matches what we have up here with that 5 factorial, 3 factorial, 2 factorial. We said this is a combination of 5 objects taken 3 at a time, and I've said if you were calculating that, it would be 5 factorial divided by 3 factorial, 5 minus 3 factorial. By the way, what is 5 minus 3? 2. So this generic equation, this definition, does work for that. This is also on your formula sheet. Oh, and yeah, in case you're wondering, it's this button here. You could go 5, choose 3, and also get the 10. The other way you'll sometimes see this written, and I hate it, but the textbook does it, is like this. A big, huge bracket with an N on the top and an R on the bottom. That's the other notation for choose. I hate that. Why not be consistent? You got permutation. Why not go with C for choose, for combination? But they're using it in the textbook, so okay. Turn the page. Example 1. I like this question, I like this question, I like this question, I like this question, I like this question. Why would I say that, Emma? You didn't hear me say it was going to be on the... You're just kind of a student that notices when a teacher tends to emphasize certain things. Okay, good. I want you to read 1A to yourself, and then read B to yourself. No talking. Brooke, read A and read B to yourself, please. This is important. can you see that in B, the order that you get picked matters? Because if you're picked first, what are you? Chairperson. If you're picked second, what are you? Okay. B is going to be a permutation. Order matters. A, do they care what order you're picked? You know what? You're in or you're out. So, how many different committees of 3 people can be formed from 7 people? This is going to be from 7 people, choose 3 people. Which is what on your calculator? Sorry? 35 as an answer. Now, by the way, what your calculator did was this. It went, write this down, 7 factorial. You're picking 3. You're leaving 4 behind. That's what your calculator did, but that choose button's way faster. Comparing that with B, okay, now order matters. There's 2 ways that you could do this. You could say fundamental counting principle, draw a blank. How many ways are there to pick the the chairperson? 7. How many ways are there to pick the treasurer? 6. I think it's obvious the same person can't be the same thing twice. I think it's obvious here you're not repeating, right? How many ways are there to pick the secretary? Or you could go from 7P3. I think either of those you get the same answer. So you guys go 7P3. This half go 7 times 6 times 5. Please, I hope you get 210 either way. Yes? Okay. I've tried to give you some strategies this unit. Drawing a blank, Scrabble bag. Here is the next big strategy. C. Suppose the group of 7 people consists of 3 males and 4 females. How many different committees can you form with 1 male and 2 females? If they break your overall group into subgroups, when I first saw this, good gosh, 10 years ago now when it was part of Math 12, I was, how the heck do I teach this? And then I went to a stats lecture by a prof named Ted Bentley. He's at Capilano College, and I always say his name because he was phenomenal. I went, here's a guy who knows not just how to explain stuff, but how to explain it with a hook and give you a clear, nice strategy to use. And so a lot of the way I'm teaching this to you is the way he taught it to me. The whole moral is if you ever end up at Capilano College, if you're ever having to take a math class, and if you got a choice, try and snag Ted Bentley. Here's what he said. Draw a bucket. So watch. I'm going to draw a bucket like this, and the bucket's going to have males and females. Draw that. How many males are there in our group grand total? 3. Draw a little 3, write a little 3 right there. How many females are there in our group grand total? 4. Now, how many males do I want to choose? Draw a little arrow, put a 1 like that. How many females do I want to choose? 2. Do you want to know how many different groups that I can form with 1 guy and 2 girls? 3 choose 1 times 4 choose 2. Can you see how that equation kind of wonderfully pops out of the bucket? This is going to be my strategy for almost any combination question. I'm going to draw a bucket. Which is what? 18? 18. Okay. 18. By the way, Rachel, here's really how I think of this. This is saying you have to have 1 male and 2 females. Let me say that again. 1 male and 2 females. In math, the word and means add everywhere except in counting and probability. If I say what's 5 and 6, what would you normally say? What's 5 and 6? What would you normally say? 11, which is true in arithmetic. In combinatorics and in probability, and means multiply. And means multiply. If you're ever doing a question and you think to yourself, hey, remember the quiz that we just did for the Lamborghini question? It was, you had a choice of this and that, and that, and that. It meant multiply each of the choices together. And means multiply. Why is that so important? D. If the group of 7 people consists of 3 males and 4 females, same as before, how many different committees of 3 people can be formed with at least 1 male? All of us underline the word at least. Because now we have to look at the different cases. Folks, I'm seeing lots of chatter. I needed focus, please, unless it was about math. If I have to have at least 1 male, what are the different possibilities here? If I got to have at least 1 guy, what are the different possibilities? I'll give you a hint. 1 guy, or 2 males, or 3 males. You know what? Let's go like this. 1 or 2 or 3. Okay? This is a job for a bucket. Males, females. Because that's what at least means, yes? We're picking a total of 3 people, and if at least one of them has to be a male, I guess that could mean you can have 1 male, or you can have 2 males, or you can have 3 males, because at least means that or more. Right? Okay. Brooke, how many males grand total in our group are we picking from at the beginning?
3.
So 3 males in the bucket. How many females in the bucket? 4. Okay. The first one, we're picking 1 male. So how many females? How many people are on the committee grand total, Brooke? No. How many people are on the committee? Read carefully. Read carefully. 3. So if 1 guy, how many girls?
2.
So 1 is going to be 3, choose 1, 4, choose 2, which, you know what, we actually kind of had right up here. What about 2? Look up, look up, look up, look up. Cross out the 1. 2. Yes? Oh, if there's 2 guys, how many girls? Cross out the 2. How many girls? 1. 2 is going to be what choose what? What choose what?
2, 2, 3, 4, 2, 1.
Sorry?
2, 2, 3.
Can't choose. From 2 people, you can't pick 3.
3, 2, 2.
Yeah, that's what I thought. Good catch. By the way, the first number's always got to be the bigger number. You can't have pick 3 people from 2 people. It doesn't work, right? So it's going to be 3, choose 2, 4, choose 1. Or cross out the 2. We're just using the same bucket. You could redraw buckets every time, but what I'm saying is you can use the same bucket over and over if you're clever and vaguely neat. How many males are we picking in the last situation? 3. How many girls then?
0.
What choose what? What choose what? 3 choose 3. 3 choose 3. 4 choose 0. What did I say a few minutes ago? What did I say in combinatorics the word and meant to do? You know what the word or means? Or means add. And means multiply, or means add. So the easiest way to do these, everyone look up. You type in the first one, 3 choose 1 times 4 choose 2. I'm permutating, thank you. 3 choose 1 times, common mistake by the way, don't get it mixed up. 4 choose 2. You type in the first one, which is 18 plus, and then the easiest thing is just to backspace, delete, change the 2 to a 1, change the 1 to a 2. 12 plus. You can try doing this all in one step. It's way quicker just to backspace and edit. It was 0 and 3. Yeah? 1. The answer is going to be 18 plus 12 plus 1. 31. 31. Okay. What does and mean? What does or mean? Add. Or means add, and means multiply. A couple of key points. So, Rosanna, from a set of n different objects, there's always fewer combinations than permutations. Because remember, permutations, we were counting the order as a different case. We were counting Erica and Mr. Dueck as different from Mr. Dueck and Erica. In combinations, you're not counting those as different. There's always fewer combinations than permutations. There always is. Oh, and R, the number of things that you're picking, Rosanna, has to be smaller than, less than the size of the group. That's why when you said 2 choose 3, doesn't work. 3 choose 2 will work. You, by the way, try it on your calculator if you're bored. If you go 2 choose 3, you got an error. Okay? For permutations, order matters, and there's going to be a trigger word. Arrangement, or arranged, or rearranged, or mixed up, but that's your trigger word where, you know what, I think they want me to count the order of things as separate cases. What are the formulas? Oh, for combinations, order does not matter. What are the formulas? NPR is n factorial all over n minus r factorial. And choose, combination, choose r is n factorial all over r factorial n minus r factorial. Example 2. Example 2 says evaluate 100 factorial divided by 3 factorial 97 factorial. Got a problem. What was the biggest factorial our calculators could handle? 70 was when it crashed. But look at the denominator. Connor, what 2 numbers are in the denominator?
397.
Do those add to 100, the top? Then you know what? Actually, this is 100 choose 3. Isn't it? That you can type into, trust me, that'll work. Try going 100 choose 3. That won't fry your calculator. What is, if you have 100 people, how many different groups of 3 can you make if you don't care about what order they're picked? One, 6, 1, 700? Okay. B. Solve that. You know what? Try guessing and checking right now on your calculator. Try going 4 choose 2, 5 choose 2, 6 choose 2, 7 choose 2. What's the answer, first of all? To tell you which one equals 21. 7 choose 2 is 21? Okay, we know the answer. Let's prove it algebraically. Okay. N choose 2 means n factorial all over 2 factorial n minus 2 factorial. That equals 21. Because that's how we defined choose. We said choose, that C there means the first thing factorial divided by the second thing factorial, the first thing minus the second thing factorial. Let me scroll up. See, it does match that. By the way, what is 2 factorial? 2. So on the next line, I'm going to stop writing the exclamation point. I'm not saying the exclamation point vanished. I'm saying, Rachel, conveniently 2 factorial happens to be 2. But if there was a 3 factorial, I'd turn it into a 6. If there was a 4 factorial, I'd turn it into a 4 times 3 times 24. But here, on the next line, I'm going to say this. What do the instructions say here in B? What does it say? It begins with the letter S, Jordan? What does it want me to do? Solve. Okay. Let's keep the n's all on the same side. Let's move that 2 over. That 2, is it on the top or the bottom of a fraction? Hello? Sorry? Bottom. So is it multiplying or is it dividing on this side if it's on the bottom? Hello? Is it on the top or the bottom of a fraction? Folks, you with me? Is it on the top or the bottom of the fraction? Bottom. So is it multiplying or is it dividing when it's on this side? It's dividing. How will I move it over? Okay. You can move it over by timesing. You guys are just... I didn't have a problem with the not knowing whether to multiply or divide, but when I said is it on the top or the bottom, come on, that we can handle. So we're going to get this. N factorial all over n minus 2 factorial. Where'd the 42 come from? Multiply the 2 over. Okay? Now what? We ask ourselves, which one's bigger, the top or the bottom on the left-hand side? What's bigger, n or n minus 2? Let's expand it. That's going to be n minus 1. Let's change colors, Mr. Dueck, so it's a little easier to follow. n minus 1, n minus 2. Stop there. Why? Because that's what I already happen to have on the bottom. Why is that so nice? Hey, Tiffany remembers seeing this before a few days ago. Now we're going to actually go and get rid of brackets. We're going to get n squared minus n equals 42. What kind of an equation is this? It's a quadratic. How do I know? It's got a squared. How do I solve a quadratic before I do anything else? N squared minus n minus 42 equals 0. Now factor it. There are going to be two numbers that multiply to negative 42 and add to negative 1. What are two numbers that multiply to negative 42 and add to negative 1? What are the roots? Sorry, Roy, brace yourself. What are the roots? And which one is Roy's date? Reject. Did we say we found 7 by guessing and checking, okay? Let's try C. Now the only problem is we're going to need more room than I left you, I think. So go like this and write C right here. N choose 2 equals 66. Draw a little line, draw a little line. Okay? So just move it up there if you need to. By the way, I see a few of you already checking. What's the answer? What choose 2 is 66? 8 choose 2, 9 choose 2, 10 choose 2, 11 choose 2. What choose 2 is 66? Sorry? 12 choose 2? So I know the answer is 12. Let's prove it. I would first of all say this is the same as n factorial divided by 2 factorial n minus 2 factorial. That equals 66. You okay with that? By the way, what is 2 factorial when you simplify 2 factorial? So look up, look up, look up, look up. You can scribble out the exclamation mark and just put a 2 there, only because it's a 2. Only because it's a 2. Right? Where is that 2? The top or the bottom of a fraction? So how will I move it over to the other side? How will I move it to the other side? I'll hide it. You're right. I will hide it. Times it over. When I do that, I'll get this. N factorial all over n minus 2 factorial. That equals whatever 66 times 2 is. 132? Now what? Expand. Which one's bigger, the top or the bottom? That's going to become n minus 1, n minus 2. Oop, stop there. And also we can expand the brackets. We'll end up with n squared minus n equals 132. What kind of an equation is this? It's quadratic. How do I know? It's got a squared. How do I solve a quadratic? Make it equal to 0. So I'm going to factor Ooh, what are two numbers that multiply to negative 132 and add to negative 1? Oh, you found it? 12 and negative 11? You're wrong. I think isn't it negative 12 and positive 11? Because I want to have it add to a negative 1. Right? Not as much as Roy's rejection. Your pain pales in comparison to our friend here. Hey, Roy, what are the roots? Hey there, negative 11. Would you mind going out for... Reject. See, what you should be saying is, yeah, but Mr. Dueck, at least I got one date. Got the 12. Okay, fair enough. Okay. Turn the page. Can you wait for a couple more minutes?
Because I feel my bag next to road.
I'm going to stop in about 5. Ready? Shh. A restaurant serves 10 flavors of ice cream. How many flavors? 10. Danielle has ordered a large sundae with 3 scoops. How many different ice cream combinations does Danielle have to choose from if she wants each scoop to be a different flavor? Does the order that they scoop the ice cream onto a sundae make a difference? In other words, if you order a sundae, if you have chocolate first, then vanilla, and then strawberry, is that really going to be different from having the strawberry in the middle? I don't think so. I'm going to argue that for a sundae, all you care about is, did you get the ice cream or didn't you? You don't care about which one they scooped first. So, how many flavors are there? How many are we choosing? 10, choose 3. Which is defined as 10 factorial over 3 factorial, 7 factorial. But what is 10 choose 3? 120? 120. Hey, you want to know another one? Pizza. Pizza toppings. If you're ever bored sitting in the, looking at the menu of a pizza place, look at the number of toppings, you can figure out how many different ways you can order a pizza. Because I don't think the order that they put the toppings on makes a difference. Whether they sprinkle the peppers on first and then the pepperoni and then the whatever. As long as it's on the pizza, you don't care. Tanya is the coach of a pole push team that consists of 9 players. 5 males, 4 females. In each competition, teams of 4 compete against each other to push their competitors out of a circle. The team that is successful wins. Shh, quiet, please. How many different 4-person teams does Tanya have to choose from for an all-male competition? Okay. I think here we have 2 different groups or subgroups. Can you see it? Males and... This is a job for a bucket. This is a job for a bucket. Males, females. How many males are there in the group grand total before we start choosing? How many females are there in the bucket? 4. Okay. How many people are we picking grand total? Read really, really carefully. Okay, I think we're making groups of 4 humans. In A, how many males are we picking? How many females then? So this is going to be what choose what? What choose what? 5 choose 4 and 4 choose 0. Before you start typing, ready? Shortcuts. What is 4 choose 0 on your calculator? Do that, just that. 1. What's 5 choose 0? What's 10 choose 0? What's 10 choose 0? What's 1,000 choose 0, do you think? What's anything choose 0? Because very often you're not going to be choosing people, that choose 0 shows up a lot. That's a shortcut worth memorizing, that when you're multiplying, it's like multiplying by 1. Will multiplying by 1 change anything at all? No. Okay. By the way, what's 4 choose 4? 1? What's 5 choose 5? What's 5 choose 5? 10 choose 10. A million choose a million. Okay, that's a 1. What's 5 choose 4? 5. In other words, this is really 5 times 1. 5. B. Okay, what are we picking for B? 2 males, so cross out the 4. I need 2 of them. Cross out the 0. I need 2 of them. By the way, instead of males and females, eventually you can start thinking clubs, spades, hearts, and diamonds. For card questions, we'll solve them all with buckets. So we're getting there. We've got to walk before we can run. What's it going to be? I think 5 choose 2 and 4 choose 2. That one I think you'll have to just type in. What is it? 60 or 616? 60. 60? 60.